Good morning to everyone. My name is D. Karthikeya. My registration number is 22BC 5035. Today my topic is application of finite automata in networking. Now we will discuss about the application of finite automata in networking. Introduction. Welcome to our presentation on the application of finite automata in networking. In this presentation, we will explore the concepts, types, and real-world applications of finite automata in field of networking. We can see the image. Now, finite automata in networking concept. We'll start a basic definition. Finite automata in networking and security applications serve as formal models representing system states and transitions, aiding in tasks such as firewall rule processing, intrusion detection, and protocol behavior analysis. Now, what is finite automata? A finite automata is a mathematical model used to represent systems that have a finite number of states and transitions between those states. In networking, finite automata are used to model and analyze the behavior of communication, protocols, packet processing, routing algorithms, and security applications. Now, how are finite automata used in networking? Finite automata are used in networking to analyze the optimize the performance of various network functions. They are particularly useful in packet processing, where they can be used to identify patterns in packets and perform actions based on those patterns. Now, for example, a firewall can use a finite automaton to detect and block traffic. Finite automata are also used in routing algorithms to determine the best path for packets to take through a network. Additionally, finite automata can be used to implement quality of service policies, which prioritize certain types of traffic over others based on their characteristic. Now, we will see the types of finite automata. Finite automata, there are three types of finite automata: DFA, NFA, and PDA. Now we will discuss about the DFA. DFA means deterministic finite automata. A DFA is a type of finite automaton where each state has exactly one transition for each input symbol. DFAs are used in network protocol analysis and verification and in intrusion detection systems. Now, we will discuss about the NFA. NFA means non-deterministic finite automata. And NFA is a type of finite automata where each state can have multiple transitions for each input symbol. NFAs are used in pattern matching and regular expression matching in network intrusion detection systems. And now we will discuss about the PDA. PDA means push down automata. A PDA is a type of finite automata that includes a stack to store information. PDAs are used in network and protocol analysis and verification, and in compilers, the parsers for programming languages. Now we will discuss about the firewall and security applications in networking. In firewall and security applications, there are three types. Not only three types, there are many types. The first type is intrusion detection system. It means finite automata can be used to detect network intrusions by modeling and identifying patterns in network traffic. Firewalls. Finite automata can be used to implement firewalls by defining rules for packet filtering and access control based on the content of the packets. Now, virus detection. Virus detection means finite automata can be used to detect viruses and malware by modeling and identifying patterns in network traffic that indicate the presence of malicious code. Now we'll move to the next page. Routing algorithm. Routing algorithm means are an important application of finite automata in networking. This algorithm determine the path the network packets take from their source to their destination. There are several types of routing algorithms, like including static routing and dynamic routing. Now we will discuss about the static routing. This type of routing uses a fixed path for all packets. Regardless of the network conditions, it is simple and efficient, but can lead to suboptimal routing in dynamic networks. Dynamic, sorry. Now we'll discuss about the routing algorithm. There are two types of routing algorithm. One is static routing and another one is dynamic routing. Static routing. This type of routing uses a fixed path for all packets regardless of the network conditions. It is simple and efficient but can lead to suboptimal routing in dynamic networks. Now, dynamic routing. Dynamic routing algorithms adjust the path of packets based on the current network conditions. This ensures optimal routing but can be more complex, resource intense than static routing. Finite automata can be used to implement routing algorithms as they are able to process packets and make decisions based on the current state of the network. This allows for efficient and effective routing in both static and dynamic networks. Now we'll move to the next page. Now we'll discuss about the quality of service. Now, what is quality of service? Quality of service refers to the ability of a network to prioritize certain types of traffic over others, ensuring that critical applications and services receive the necessary bandwidth and resource to function properly. We can see the picture. Now, quality of service in finite automata. We'll discuss about the quality of service in finite automata. Finite automata can be used to implement quality of service policies by processing packets and determining their priority based on predefined rules. This allows for efficient and effective management of network resources, ensuring that critical traffic is given priority over less important traffic. This is quality of service. Now we'll understand now understanding of finite automata. We'll move to the next page. What are finite automata? Overview of finite automata. Finite automata. Finite automata are mathematical models used to recognize patterns within strings. They are used in computer science to solve problems related regular expressions, lexical analysis, and parsing. There are two types of finite automata: DFA and NFA. DFA is deterministic finite automata. NFA is not deterministic finite automata. Now we'll discuss about the DFA and NFA. DFA, deterministic finite automata. A deterministic finite automata is a mathematical model of computation that recognizes a regular language. It has a finite set of states, a finite set of input symbols, a transition function, and a design start state and set of accept states. Key characteristics of deterministic finite automata. It can only be in one state at a time. For each input symbol, there is exactly one transition state. It accepts or rejects a string based on whatever it ends up in an accept state or not. Now, use cases. DFS. DFS are commonly used in computer science and electrical engineering for tasks such as pattern matching, lexical analysis, and hardware design. Now we will discuss about the NFA, non-deterministic finite automata. Definition of the NFA is a non-deterministic finite automata is a type of finite automaton that allows for multiple possible transitions for each state. Unlike a deterministic finite automata DFA, which has only one possible transition for each state for any given input symbol. Now we discuss about the formula definition. An NFA can be formally defined as a phi tuple of states Q, sigma, Q naught, and F, and where Q is a finite set of state, sigma is a finite set of input symbols, the alphabet, epsilon is a state, and Q naught is a starting state, and F is a final state. Now, automata and firewall rules. Now we'll discuss about the automata and firewall rules. Stateful packet inspection and regular expression matching. Now, stateful packet inspection (SPI) is a firewall technology that uses a finite state machine to track the state of network connections. This allows the firewall to make more intelligent decisions about which packets to allow or block based on the context of the connection. Now, regular expression matching. Firewalls can also use finite automata to match network traffic against regular expressions. This allows for more granular control over which packets are allowed or blocked based on specific patterns or signatures in the traffic. Now we will move to the next page. Now we'll discuss about the networking and the types of the networking, that is intrusion detection and prevention. Okay, finite automata play a crucial role in detecting and preventing intrusions in network security. They are used to identify patterns of malicious behavior in network traffic and block them before they can use harm. Now we'll discuss about the how automata are used in the firewall rules. Automata are used to create firewall rules that can detect and block malicious traffic. By analyzing the data packets and looking for specific patterns, the firewall can determine if the traffic is legitimate or not. If it is not, the firewall can use an automata to block the traffic and prevent any further damage to the network. Now, intrusion detection and prevention with automata. You can refer the images for the automata used in the firewall rules and intrusion detection and prevention with automata. Automata are also used in intrusion detection and prevention systems. By analyzing network traffic and comparing it to known patterns of malicious behavior, the system can detect and prevent attacks before they can cause any damage. This is done using finite automata that are designed to recognize specific patterns of behavior and take action to block them. Now we'll move to the next page. Now, quality of service. This is also type of the networking in the finite automata. Quality of services. What is quality of services? Why is quality of services important? How can automata can be used in quality of services management? Now we will discuss about these three topics. What is quality of service? Quality of service refers to ability of a network to provide better service to certain types of traffic over various underlying technologies, including IP, ATM, and frame relay. Now we'll discuss about the why is quality of service important. Quality of service is essential for ensuring that network resources are used effectively and efficiently, particularly in situations where there is high demand for bandwidth. It also helps to ensure that critical applications such as voice and video receive the necessary bandwidth and priority to function optimally. Now we'll discuss about the how can automata be used in quality of service management. Yes, how automata. Now we'll discuss. Automata can be used to manage quality of services by providing a way to dynamically allocate resources based on traffic patterns and priorities. For example, an automata can bound it to monitor network traffic and adjust quality of services. Now we'll move to the next page. Now we'll discuss about the automata in quality of service management. Okay, quality of service refers to ability of a network to provide better service to selected network traffic over various technologies, including frame relay, asynchronous transfer mode ATM, Ethernet, and 802.1 networks, SONET, SONET, and IP routed networks that may use any or all of these underlying technologies. Quality of service management with automata. Automata can be used to manage quality of service, providing a framework for analyzing and controlling network traffic by using finite automata machines to model network behavior and traffic patterns. Automata can help Network administrators optimize network performances, prioritize traffic, and ensure that critical applications receive the resources they need to function properly. Now, finally, we'll discuss about the conclusion. Conclusion. Finite automata have a wide range of applications in networking and offer a powerful tool for solving complex problems. And by understanding the concept of finite automata and the different types of available, we can apply this knowledge to real world scenarios in packet processing, firewall and security applications, routing algorithms, and quality of services. As networking technology continues to evolve, it is important to stay up to date with the latest advancements and tools available. Finite automata provide a valuable resource for network engineers and administrators, helping to improve efficiency, security, and overall network performance. Thank you for your time and attention. We hope this presentation has provided valuable insights into the application of finite automata in networking. Thanking you. Signing off. D. Kartikeya, 22 BC 5035. Thank you.